We are going to look at those same key features we looked at in the other video, but this time we are going to apply those ideas directly to the exponential graphs that we're learning about. All right, let's consider this one. Y equals 12 to the x power. Well, I know this one is exponential because I have an x in the exponent. My variable is up there in the exponent. So the question is, does this one model growth or does this one model decay? Well, my x is positive and my 12 is bigger than 1, so this is going to be a growth model. It's going to be going upwards. It's going to be getting bigger. So the anchor point. Do you remember how we found the anchor point? Anything to the 0 power other than 0 itself is 1. So the anchor point is the point 0, 1. It happens to also be the y-intercept. And this will be true until we start doing translations. It's always going to be there. And then the asymptote. Okay, now think about what this graph looks like. If it's a growth model, it's going up quickly to the right and it's flattening out on the left. So the asymptote, which I'm having trouble aiming with my finger there, the asymptote is on the left-hand side, on the negative side of the x-axis. All right, so if I want to draw my growth model, I will start here slightly above. Remember, you never actually reach the asymptote. It's going to be slightly above the x-axis and then shoot up as I go to the right. Arrows on both the left and the right. Okay, so there is my graph of 12 to the x. All right, let's look at some key features of that graph. Well, I graphed it for us in Desmos. Look right here. Remember what we talked about? You have to be smarter than your calculator. Desmos can't handle the asymptote very well. No technology can. So you have to know that this is not actually on the x-axis. It's actually slightly above, but the technology just lacks the ability to graph that well. You can see the anchor point right here, though, at 0, 1. Okay, so domain. Let's think about what that means. Domain was all the possible x values. Well, remember when we drew this one, we put arrows on both ends, so Desmos really should have given me an arrow here and an arrow here. And if I see that, this arrow down here tells me it's going on and on forever left. This arrow right here tells me it's going on and on forever right. It is going up, but you can see that the line is also going right as it's going up. So all the way to the left is negative infinity, all the way to the right is positive infinity. And remember we said we can abbreviate that using our all real numbers symbol. Okay, now range. Range is all the possible y values, and we read range bottom to top. So the lowest that this one goes, now this is a little bit tricky. This goes on and on and on forever down, but remember it never touches the asymptote. It never gets to where y equals 0. No matter what the exponent is, y is never going to actually be equal to 0. So what that means is the range is from 0 to infinity, because you can see on this side that arrow tells me it's going up, but it's just that 0 is not included. So unlike the parabolas, we're going to put a parentheses on 0. We always put parentheses on infinity. It's never included. But in this case, we're going to put a parentheses on that 0 as well because it never actually reaches it. Okay, so x-intercept. All right, so think about what the x-intercept means. In order to find the x-intercept, we set y equal to 0 and we solve for x. It's where it crosses the x-axis. Well, but look, this one never crosses the x-axis. Remember, that's where my asymptote is. It never quite gets down there. So what that tells me is that I don't have an x-intercept. So when I go to do this on a test or a quiz, I can't leave it blank. If I leave it blank, what that says to my teacher is, I don't know what the answer to this question is. So if you want to tell me that you do know the answer, what you need to say is that there isn't one or none or not applicable or something that tells me you know it never actually reaches the x-axis. All right, how about the y-intercept? Well, the y-intercept is our anchor point. Until we do translations, that's always going to be our y-intercept, and that is the point 0, 1, because anything other than 0 raised to the 0 power is 1. Okay, let's see what else we can find out about this one. Let's look at intervals of positive and negative. Okay, now think about what that meant. Positive means above the x-axis, negative means below the x-axis. So again, look at this part of the graph right here. It's not actually on the x-axis, it's actually above the x-axis. So when I go to color in blue all my parts that are above the x-axis, I'm going to color this even though it looks like it's sitting on the x-axis. Arrows on both ends. So the intervals for positive, in this case, are negative infinity, because it's going on and on forever left, and positive infinity, because it's going on and on forever right, and there's no jumps and there's no gaps. So then where is this one negative? Where is this one below the x-axis? Well, nowhere. So you can say none, or there isn't one, or it's never below the x-axis, or something that tells me you understand what the answer to this question is. Don't leave it blank. Okay, let's keep looking. Increasing and decreasing. Okay, so increasing means it's going up. Decreasing means it's going down. So look at the shape of this one. We always read our graphs from left to right. And as I am moving from left to right, you can see that this one is constantly going up. It's going up really fast over here on the right-hand side. It's going up much more slowly over here on the left-hand side, but as I move across the graph from left to right, it is going up. So what should I color orange? Where is it decreasing? Where is it going down? Well, the answer to that question is nowhere. So just like before, increasing is going to be negative infinity to positive infinity, and then decreasing, where it's going down, that is going to be none, or it's not, or it never goes down, or something that means that, something that I'll know you know what it means. Okay, now we didn't look at this one in our last video. This one is a reminder from what you guys did in Algebra 2 in behavior. Okay, so let's remember what these symbols mean. This means as x is approaching infinity, as x gets closer and closer and closer to infinity. Okay, so looking at my x-axis, is infinity over here on the right, or is infinity over here on the left? Well, positive infinity is this way. It's a very, very large number. So this means I'm moving to the right. So basically, this is saying as x is moving to the right, what is y doing? What direction is y going? And then this one, x approaches negative infinity, that's asking about the left. I just realized I made my all real number symbol right there instead of right. There we go. All right, so as x is approaching infinity, as I move on my graph to the right, what is y approaching? What is y getting close to as x moves further and further and further to the right? Remember, I've got that arrow right there. That tells me that y is approaching infinity as well. As x gets bigger, y is also getting bigger. Okay, let's look at what happens as x approaches negative infinity. This is one of those rare cases when we're going to read to the right. So let's go this way. As x is approaching negative infinity, as I am moving to the left on my graph, what is it getting close to? Well, remember, it never crosses that asymptote, but it gets closer and closer and closer to it. And what y value does that asymptote represent? Well, that's the y value of 0. On the x-axis, y equals 0. So what this tells me is as x is moving to the left, as x is getting smaller and smaller and smaller and smaller, y is also getting smaller, but it's flattening out on 0. It can't go past 0. All right, let's try this one. Y equals 5/16 to the x. Okay, so is this one going to be growth or decay? Well, my x is positive and my 5/16 is less than 1, so this is going to be a decay model. It's going to go down. The anchor point is going to be the same because anything other than 0 raised to the 0 power equals 1. It doesn't matter what that anything is, it's always going to be 1. Now, where's the asymptote this time? Well, if it's a decay model, as I move to the right, it's going down. So therefore, my asymptote is going to be on the right-hand side of the x-axis. And if I connect the dots, this is a decay model, so it's going to start high, go through the anchor point, and then go next to the asymptote, but remember it never actually touches, never actually crosses. It stays slightly above it all the time. All right, let's look at our key features here. So domain. Domain is all real numbers. Remember, we have those understood arrows right here. We're never going to get arrows on our technology. So domain, how far to the left does this one go and how far to the right? Well, it's going to go forever left. That's what this arrow is telling me. It is going up, but it's also going left. You can see how it's kind of leaning out towards the left right there. Negative infinity to positive infinity. This arrow telling me it's going on and on forever to the right. Okay, how about range? Again, we read range from bottom to top. Always start the lowest that it can go and see how high. Well, it's flattening out over here. And what y value is it where it's flattening out? Just like last time, it's flattening out at 0. So the range goes from 0 to positive infinity because it's going forever up. But remember, 0 itself is not included because it's an asymptote. It never actually reaches that point. Okay, now what did we say last time about the x-intercept? Right, because it doesn't touch the x-axis, there is not an x-intercept. It never actually reaches the x-axis. And then the y-intercept, that was our anchor point. So the y-intercept on all of these, until we do translations, is going to be the point 0, 1. All right, let's look at positive and negative. I turned my graph around. Let's see what that's going to affect. So positive is above the x-axis. And remember over here, it is actually above the x-axis. It doesn't look like it, but it actually is. So when I go to color it with blue, I'm going to color across the whole thing because it's all above the x-axis. And where am I going to color it red? Where is it negative? Well, it's not negative at all. So my positive then will be negative infinity to positive infinity. And I could use my all real number symbol on that one if I want to. Goes on and on forever down as it goes from the left to the right. And negative is going to be none. It never goes below the x-axis. Okay, how about increasing and decreasing? So increasing means going up, decreasing means going down. And as I read this one from left to right, at no point is it going up. Do you see that it's constantly going down? So when I color this one, I'll put my arrows on there, and I'm going to color it orange because it is constantly going down. At no point is it going up. So that when I write my answers, for increasing, I'm going to write none. And for decreasing, I'm going to write my all real numbers, negative infinity to positive infinity. Okay, so that part changes. I noticed that the positive and negative doesn't change whether it is a decay model or whether it's a growth model. It's always positive. However, if it's a growth model, it is always increasing. And if it's a decay model, it is always decreasing. All right, let's look at that in behavior. Fill in those last blanks. Okay, so as x approaches infinity, which way does that mean that we are going? That means we're going to the right. We're going this way. So as x gets larger and larger and larger, what is y getting closer and closer and closer to? What is y approaching? Well, in this case, it's approaching that asymptote, so it is going to 0. All right, now let's go the opposite way. As x is approaching negative infinity, all right, that means x is going to the left. And I'm going to read my graph towards the left, kind of reading it backwards. I'm reading towards the left. And I can see that arrow telling me that y is going up. So as I go left, as x gets smaller, y is going up. Y is getting larger. So that is going to be positive infinity. And you can see that, oops, that's the opposite of what we had before. Before, when it was going to the right, y was going up. And when it was going to the left, y was going to 0. And here I have the opposite. Right goes to 0 and left goes to infinity. And I'm just reading that right off my graph.